Sorry for that technical delay. All good now. So very happy to welcome Monnie McGee. Dr. Monnie McGee is an associate professor in biostatistics and bioinformatics in the Department of Statistics and Data Science at SMU in Dallas, Texas. Previously as a BA in mathematics and English from Austin College in Sherman, Texas, and an MA and PhD degrees in statistics from Rice University. She specializes in research of high throughput biological data, expert in correction, normalization, and hypothesis testing. But she's also interested in sports analytics, particularly the analysis of individual team sports like track and field, swimming and diving, and gymnastics. And today's talk is going to focus on sources of bias in the judging of diving competition. So let's welcome Monnie.
Thank you all very much for being here. This is a great crowd, overflow capacity, that's wonderful. I also want to thank the organizers for inviting me for something very different from maybe what you've seen before at this sports analytics conference. It's great being the third speaker because I can learn from the first two. So what I've learned from the first two is Sarah reminded me that I need a problem to solve. And I got into the trees a little bit much with these data, but my problem that I wanted to solve was what is the optimal dive list, and I'll explain what a dive list is in a minute, to maximize a diver's potential score in a diving meet. That was the problem I wanted to solve. What I'm going to present, though, is a bunch of descriptive statistics that hopefully lead to that problem at some point. The thing that Albert reminded me of was I'm curious about whether there is a Pythagorean theorem for diving and track and field. So that was the other thing I was thinking about. But let's get into this talk. So why study diving? People are throwing themselves off headfirst off 4-story buildings. Who wouldn't want to watch? Juicy tales of nationalistic intrigue. Swimming and diving is one of the top 3 favorite sports in Summer Olympics. That also includes other aquatic sports like water polo as well. Diving is beautiful. If you've ever watched it, it is amazing and wonderful to watch. Degree of difficulty is a genderless quantity, and I'll explain more about what degree of difficulty is and how it applies to all divers. Not many people are studying it. Lots of technology to develop. Lots of statistical methodology to develop. And loads of data available. I hope to convince you of 2, 3, and 4 by the time I'm finished with this talk. And my kids got me into it. So that's definitely the number 1 reason. So let's talk about some juicy tales of bias. Of course, you may have heard about scandals in gymnastics and ice skating in particular, where we have had judges banned for bias, for example, from this article. There's also some bias, maybe evidence of bias in the 2000 Olympic diving competition. There's figure skating bias, and what's interesting about these is that because of these articles about judging bias, gymnastics and figure skating have changed their scoring methods. And there's, I guess, a little bit of a debate about whether or not that's really a good thing, that it's actually changed things. Of course, there's an article from The Economist about how to detect nationalism in winter sport judges, and this is actually from 2022, so about a year ago. And then there's this one, about ski jumping gets Olympic judging right and figure skating gets it wrong. And this article argues that it's not so much about the scoring system as it is about the culture of the sport. So I want to talk a little bit about the culture of the sport of diving too. So diving has an international organization called the Fédération Internationale de Natation, FINA for short. And it warns judges. Judges about different types of bias, not just nationalistic bias or team bias, but also these other kinds of biases. And they actually have a 3-part sort of judging school, I guess if you will, or seminar to help judges overcome these kinds of biases. So there's reputation bias, which of course have in almost every judge sport, where a diver or an ice skater or a gymnast with a really good reputation is going to get higher scores just because of their reputation. We also have seeding bias, which is related to reputation bias, where if a diver is seeded highly in a particular competition, maybe that diver gets a little more points just for being seeded highly. We have some dive order bias. So this is something that I wanted to investigate, where we have the order of the dives in the competition. And I'm not talking about the order of the divers. That's more conformity bias. I'm talking about the order of the dives. So if a diver does a 1.5 in a pike position forward first and then does a backward 1.5, is that a better combination, say, than a backward double flip and then a 1.5 in a pike position? So that's another kind of thing I'm interested in. Difficulty bias and round bias. So difficulty bias is this idea that just by doing something more difficult, you get higher scores. Like there's a little bit of a leniency for doing something difficult. And then round bias is this idea that the diving competitions that I'm talking about are competitions that have 11 rounds. So after you've watched 26 divers go through 11 rounds of diving, what's the judges, are they still judging the same way as they were judging at the very beginning? They do get a break in the middle, but still, it's quite a long competition. So, actually, I'm talking about statistical bias is what I'm really talking about. Those 6 things that I just mentioned earlier are really things that can be measured with statistical bias. So I'm not talking about nationalistic bias, and I don't have any juicy tales of high school rivalry or college rivalry to talk about with this. I actually don't have information on the affiliation of the judges in this particular data set that I have. What I do have information on are their scores. And so I want to look at the true diver ability and how well is that estimated by the judges' scores. That is our estimate of diver ability. And I'm going to look about round bias and difficulty bias. So those are the 2 things I want to focus on today. So let me talk a little bit about scoring for high school diving. Scores are given independently by 3 to 7 judges per meet. The only time when you don't have an independent assessment of the score is if the diver fails the dive. So the judges all have to agree that the diver did not complete the number of rotations or twist or whatever they said they were going to do. The degree of difficulty is determined by FINA. This is set in stone. It does not move, and it is the same for every level of the sport and both genders. So it is something that is that regardless of if you're high school, 1.5 in a pike position is the same degree of difficulty as if you're an Olympic diver. So this is something that is consistent across all levels of the sport. In the dive meets that I'm talking about, we've got 11 dives, 5 of which are voluntary, so the degree of difficulty has to be less than or equal to 9.0 for the sum of those 5 dives. And the same thing for the 6 optional dives, you have degree of difficulty greater than or equal to 11. Divers have to perform at least 2 dives in each direction. And for those of you who don't know dives, here are my cute little stick figures. So the forward dive, of course, goes forward. You walk off the front of the board, you do something, and you land head first into the water. The backward dive or inward dive, is your back faces the pool, and then you rotate inward toward the board. Very scary. You also have the backward dive where you face the back of the pool and you rotate feet overhead, backward. Then you have the twist, which is any aerial motion in the middle of the dive, and a twist can be incorporated into any kind of dive. And you have the reverse, where you go off the front of the board and rotate backward toward the board. Also very scary, usually considered the most difficult kind of dive. At least it's the one that divers learn the last when they're learning different dives. I have the handstand on here too. This is not relevant for the data that I have. I'm talking about springboard diving. I'm also talking about 1 meter springboard diving in this talk. So I'm not talking about people throwing themselves off the equivalent of a 4-story building, which is 10-meter platform diving. So we don't have handstand position in this particular talk. So the scores go from 0 to 10 in half-point increments. The net score is the sum of the middle 3 scores per round, and this is true regardless of the number of judges. It's always the middle 3 scores. The award is the net score times the degree of difficulty, and that's a per round score. And so you sum up the awards to get the diver's total meet score, and the ordinal places are determined, of course, by the total meet score. So the highest score wins, and here's an example here. So let's say I have 5 judges that judge a 1.5 pike in a forward position as a degree of difficulty of 1.7. And so you see the middle 3 scores are summed up and they multiplied by the degree of difficulty, and then you get a score for that round. And then you have 11 such scores that add up to be the total meet score. So that's scoring. So that's how we estimate diving ability. How do we measure true diving ability? So let's talk about some previous work that I've done trying to do this. One of the ways I've tried to do this is with video evidence. So this is a paper that was published last year in PLOS One. We have videos and scores collected live during a high school regional meet, and I am talking about high school diving at the regional and state level. That's what I'm talking about. I used video footage to measure the angle of entry, the distance of the entry from the board, the height of the splash, and the height of the dive. Now, what actually wound up happening, and you'll see in these pictures, this is an angle of entry at the top. This diver is going in almost perfectly straight. So you can see that but you can't really tell this from this particular shot. Maybe you can tell it better from the bottom shot. But we wound up, instead of measuring height of the splash, we wound up measuring 2 angles of entry. The first angle of entry was when the diver's hands hit the water, or the first part of the diver's body to hit the water to the waist. And the second angle of entry was the legs, from the waist to the feet. What did that angle look like? And that's kind of a surrogate for the height of the splash, because the height of the splash was super hard to measure with video. And so we use these in a regression model to predict the judges' scores. Now, something I want to say here is that we did this by hand using Final Cut Pro. So this was really laborious. And I know that there are better ways. I say we. My graduate student did it, okay? Honestly, okay? So she spent hundreds of hours doing all of this work on video, but she was actually a film major in addition to getting her statistics PhD. She kind of loved it. So anyway, but this was really laborious, and I know that there are much better methods of doing this now, and I would love to incorporate those into the next round of this sort of thing. So here's the model that we came up with, and of course we put both genders in together. So we have a male and is one of our variables. You can see the levels of p-values here for each one of these. You can see that the only one that does have the larger p-value is the degree of difficulty, which I find interesting, especially for what's following. Most of these are measuring things that we think are things that the judges are looking for. And I think that winds up to be true. So so we have, again, notice that this first angle, the angle with the diver's torso or with the water does not enter into this, but the second angle does, and I think that's because, as I mentioned earlier, it's the height of the splash. This distance is the distance from the board that the diver enters the water, which is important. You want to be close to the board, but not too close to the board. So if a diver ever gets this reaction, it means they went too close to the board, okay? So you don't want that. And also the height of the dive, at the apex of the dive. Now, so we put these into a regression model, and I just want to show how this worked out with the ordinal scores. So this is the ordinal scores for the girls. Over here, we have the meet total, so that's the actual meet total from the meet, the raw total, or the total from the video measurements, and the regression total, which is the prediction from the regression model. So you can see here, just using our video measurements, we have that we switch places 3 and 4 in our model from what the judges said. Now that's important for this particular meet because places 1, 2, and 3 go on to state. So if you don't get into top 3 places, your season's over. So this is really important, this difference. The regression model gets the top 3 places right. Now, I'm assuming that the judges' scores are the gold standard here. So but it gets them in different positions. But in this case, yeah, it's nice to have bragging rights that you won the regional meet and you have a gold medal in the regional meet, but you still get to go to state. So that's okay. And over here with the men, we have a really interesting position, and that is that diver 10, actually the diver that was ranked 10th with the judges' scores gets ranked 2nd with our raw ranks. And we kind of looked into this a little bit because it was weird, and we discovered that diver that got ranked 2nd down here was actually going, one instance had too far from the boards. This is an outlier issue, really. And then with the regression ranks, they see that, again, we have the divers in a different order, but at least the top 3 are the same ones. So what am I saying here? I'm saying that it looks like the judges are really good at determining what they say they are trying to determine. And that was something that we actually didn't expect. I was kind of hoping to show the opposite. But because my daughter finished 6th in this. Anyway. So what if we don't have videos? We still want to estimate this thing, but what if we don't have videos? So we have some precedents for this using scores from the previous scores. So we have gymnastics, of course, use a median control score. So this is APJ here on this slide is the judge's J's mark for performance P. We also have figure skating does a median assessment score and judges deviations from it. So they call this a discrepancy. And Olympic diving in 2011 had the discrepancy as the difference between a particular judge's score and the untrimmed mean of all judges' scores. So this is the idea of using previous marks or an average or a center measurement of previous marks to determine a diver's true ability. So what we used is a variation on all of this. We have the discrepancy is the net score minus the competency. So our competency is defined as a mean over all meets and rounds of the net score for a particular diver D, or dive, I should say. So we have 261 meets and 1,911 divers with 86 dives. That's actually the physical dives performed, and 11 rounds. We have about 39,000 different dives performed. That's not divers, that's dives performed. We are treating the dives as independent because in a meet of 11 rounds, there's typically about a 20-minute wait or so between your rounds, so it's kind of like a reset time. And we gathered all this data from divemeets.com, which is a huge source of diving data. And it's got diving data from all meets, I think from 2010, maybe even farther back on. And it has high school, club, and maybe even some collegiate meets. So we're looking at the round of competition, the difficulty of the dive, the age of the diver, and the gender of the diver as whether or not those have some effect on this discrepancy. So what you're going to see next is a lot of pretty pictures. So instead of equations, but I also have just a reminder that the discrepancy, if the score is greater than the competency, then the discrepancy is positive, and that means the judges are favoring the diver, and opposite if the discrepancy is negative. So some results. This is a ridgeline plot, which is my current favorite type of plot. So what it does is on the horizontal axis, I have the discrepancy, and on the vertical axis, we have categories for each variable that I'm examining. This one is for gender. The red line from the left here, on the left side of the graph, all the way to the end, that is the 2.5th percentile. Over here is the 97.5th percentile. The black line in the middle is the median, and this is the 0 line. So you can see that these, for gender, we do not see a difference in terms of the discrepancy for judges' scores. Now I have some other things I examined. So this is the age of the diver. Here's the 0 line. You can see that as divers get older, so maybe you can't see if you're in the back of the room, but this is from 14 to 19 in perfect order. So older divers tend to have more lenient scores, but that may also be a reflection of their better experience as well, and more control over their body. Also, this is the degree of difficulty divided up into 4 categories. So I had beginner, intermediate, advanced, and expert. Expert is the most difficult dives. Obviously, beginner is not necessarily a reflection of the diver, it's just a reflection of the dive. And you can see that the judges' scores are more lenient for the beginning ones rather than the expert ones. And this is kind of the opposite of what we thought. We thought that the difficulty bias would be toward expert dives, but it doesn't seem to be that way. The discrepancy of dive direction, this is whether or not you're doing a reverse, forward, backward, twist, or inward. That you can see that there's a little bit of positive bias for the reverse, but everything else seems to be unbiased. Maybe there's a tiny bit of negative bias for the twist. And then we have dive position, which is tuck, straight, pike, or free. So the free position is usually associated with the twist, and the tuck position is generally thought of as the easiest position. So again, we see that there's a bit of more favoritism toward the toward the tuck in this case. So now I broke out the degree of difficulty by the actual numbers that I had with a little bit of gathering of data. Down here, we didn't have a lot of dives that had 2.8 or higher difficulty, so these are gathered like this. 2.8 represents 2.7 to 2.9. The 3 represents anything above 3. I think the highest difficulty in this particular meet was a 3.4. Here's the 0 line, so you can see, and and there's a horizontal line. So this will help you see what's going on. This horizontal line intersects the vertical line at the place where the diver, where we have a 0 unbiased estimate here, where this red line is on top of a black line, basically. So we have the top, the 1.5 to 1.6, these difficulties here, those are the smaller difficulties. So we're seeing a positive bias, again, for small difficulty. Down here at the bottom, we have mostly the larger, more difficult dives, except for here's 1.9 and 1.8 down here. So it's not a perfect, it's not exactly in numerical order, but in general, we see the less difficult dives tend to have a favorited in terms of the judges rather than the more difficult dives. So now let's look at round bias. So this is a different plot. We have the dive order on the vertical axis, and the discrepancy is now on the dive order is on the horizontal axis. The difficulty or discrepancy is on the vertical axis, and each one of these represents a different meet. Each panel is a different meet, and I randomly selected the meets just to see what things look like. And each black line is the discrepancy for a diver. So you can see one thing is that we have meets that have 1 diver and meets that have, I don't know how many divers here, like 200 or something in there? No, probably more like 80 in this particular meet. So there's a large variability in the number of divers. There's also quite a bit of variability in their discrepancy. So this really does depend on the dive. Or the round. And also this blue line is a low S line, which is supposed to give us an average or a fit over all these discrepancies. And so you can see that regardless of the meet and the number of divers in the meet, that there does seem to be some relationship between the discrepancy in the round. So there does seem to be a bit of a round bias. So we have evidence of the round of competition, the difficulty of the dive being related to discrepancy. We have little evidence of the age, maybe the gender, but not very much there. And I didn't examine the order in which the dives were performed or the order within the competition, and I actually do not have information on the sequential order of the divers themselves. So I put this all in a mixed effect model because what you just saw with the pictures is independent evaluation of each one of the things I wanted to examine. So now I wanted to put them all together into a model. So we have a random effect for the diver. And we have on the left here, we have the girls. There are 1,045 girls. And we can see that the degree of difficulty turns out to be the largest thing for both the girls and the boys in this particular one. Age and round. Round does have this negative effect, which we saw on the slide in the plots. Age, not so much, but the degree of difficulty is really the largest thing that's contributing to any kind of discrepancy. And you can also see that the degree of difficulty is less in the negative direction for the boys than it is for the girls. We also had fixed effects for position and direction. But those were left out of the model because they are kind of correlated with the degree of difficulty. So the degree of difficulty seems to be the most important thing in determining the judges' scores, but the degree of difficulty is in the opposite direction of what we thought that this that the judges would do. So we're repeating. There's some things I didn't account for in this model. Round is a repeated measure. I treated it as independent. We have some nesting, divers nested within meet, but we also have a problem in that not every diver competes in every meet. We have the same dives in different orders within a meet, so that's something to take into account at some point. And of course, every meet has a different panel of judges. So there's some way to incorporate that into the model as well. So the dive meets data are also not from controlled experiments. This is diving in the wild, and confounding factors exist that I can't take into account. So when I gave this talk at JSM, someone mentioned, well, what about leotard bias or swimsuit bias? Like the color of the leotard or the type of the leotard or swimsuit in this case might have an effect. I was like, well, I don't have that information, so I can't tell you about that. Of course. So now I'm coming to the end of my talk, and I hope that I've convinced you of at least 2, 3, and 4. I think you already knew that diving is a beautiful sport, and I hope that you will join me, and some of you will join me in looking into this data to try to figure out more information and develop methodology for sports like diving and track and field and other individual or event player sports. Thank you very much to Gabe Downey and Zachary Berg, who were the ones who provided me this data. And also, here's my references, and thanks again for the organizers.
All right, thank you, Monnie, for the fantastic talk. We'll have time for some questions before break. We'll start here, and then we're going to try out our Steinberg auditorium question system. We'll see if it works.
Thank you for your talk. So for starters, I don't really know anything about diving or scoring particularly. I imagine it's, like in the movies, the judge is holding up like a number 1 to 10. I'm wondering, like, the degree of difficulty part of this, because it's biased and favored of lower difficulty dives, is it possible there's some sort of like human element? They don't want to give like a really bad score on a bad dive or something like that? And if so, how would you deal with that?
Yes, it's possible. Anything's possible. I guess I'm not sure how I would deal with that. What's coming to mind right now is that the video evidence might be quite important in that. So if you can marry the video evidence with the judges' scores, that would help. But just having the scores, I can't tell whether or not this was a really bad dive that was given marks because the judge felt sorry for the diver instead. So, but generally, in my experience, judges don't do that.
Hi, great talk.
Thank you.
I'm curious, what technology do you think there is to develop from the data collection side of diving data? I mean, I work at a company that does some data collection itself. Are you thinking mostly optical tracking data of divers as they happen, or are you thinking something else?
I am thinking optical tracking data, or at the very least, some sort of way to measure where the dive is at its height and the distance from the board. Those are the two that I think can be measured quite easily. I know that in swimming, for example, they have touch pads where you can measure exactly when the swimmer touches the wall, so I expect something like that maybe could be measured for diving. The other thing I'm thinking about is just video evidence in general. If you could track, like, and I thought about this morning walking over here, is that if you could track like the whole trajectory of the dive, the spin, everything, and that would be amazing technology, but it would also be really cutting-edge statistical methodology as well.
I think we have a question here in Steinberg. Can you guys hear us?
Yes.
This is the Phantom of the Opera. Go ahead.
Hi. So to follow up on that, it looks like the judges are pretty good. Like there's bias that does creep in here and there. Do you think, like with what we're doing right now, the judges themselves would feel comfortable being augmented by this kind of additional tech? Or from what you know of them, would they be a little more defensive about being replaced?
Oh, I imagine they'd be a little bit defensive. But I do know it's hard to get judges. So this might, if you can, you not have to have 7 judges for a meet, maybe that would be helpful for a lot of different reasons. But for the Olympic level, I'm not sure that maybe this would never work there. But I think what's probably the best application of this would be for coaches, to be able to track, to be able to make this optimal dive list that I talked about. I feel funny, I'm like talking to the ceiling here. I don't know where to direct my gaze. But yeah, for coaches maybe, and for the divers themselves.
Thank you.
All right, we're going to now move to our break. So let's thank Dr. Monnie McGee and Dr. Albert Cohen for their great talks. Also, more swag for invited speaker.